So it's time to record some video at work, and I'm wondering, where can I record? Could I do it on that surface? Could I do it... nope, not that surface, too cluttered. Not that surface, it's far too cluttered. Far too cluttered, clutter. I'm thinking the sound department's flight cases look quite empty, so let's make a video here. So let's take this to bits. It's a power bank that was given to me by the crew chief, Vince. And he brought this one from China, I think it was. And very common to others of this range. It says, "Wonderful life because of you." So, let's pop it out. Guys, can we stop throwing missiles? That's so tacky. He's just throwing his colon at me. I'm just going to eat it. Oh, that's a bit soft now, guys. Yeah, I'd recommend throwing them in the bin. So here's a power bank, which has the usual arrangement. It's got the 2 ports, and yes, and if you hold the button in, it will light the light. And it's got the 4 LEDs that indicate the level of charge. And once I've started taking this to bits, guys, once I've started taking this to bits, guys, just so you know, there's no stopping. So let's pop the end off, because the end of these usually has a sticker on it. Oh, yes. Invasion of the black pussy, apparently. That's also going to get torn down later on. So let's and the moose, because this is the sound department's desk, the moose has to make an appearance. This is sound department moose, and that's a lollipop. That's, technically speaking, it's product placement. They're not being very helpful. I really shouldn't make videos at work. It's just going to result in oddity. And there's no going back now. I'll just put the jam to the side here. Oh, it's sticky. And to crew brew beer. I could drink that actually. So let's get the end cap off this and see what's inside. This is another of these bogus solar-powered power banks that, you know, you put it in the sunshine, 2 things are going to happen. Either it's not going to put much charge in at all, given the exaggerated ratings of these, or it will bake it in the sunshine and then it will just go on fire, or puff up. So taking this off, it's got foam. It has quite a stack of what looks like lithium cells in there. That's interesting. I think I might have to take the other end of this off. I'll just pop the lollipops out the way here. So let's see if I can get in this end. No. I hope he doesn't want this back afterwards. It's quite hard getting these labels off without stabbing myself. Okay, so here it comes. And more screws. And this should give us access to the circuit board, which I'm going to draw out very gingerly, because this is where there's usually lots of random connections in the vicinity of the metal casing. And I don't want to short everything out. You guys want me to short everything out? You're so mean. Oh, let's oh. Okay, so I've got the lithium pack, which is not budging. Oh, that is quite tight in there. I've got the solar panel. So, guys, that's not helpful. No, it's perverted. It's just weird. This is stuck in, Vince. Yeah. That's not. You're just going to make me short this out with excitement. Right. Okay. This appears to be stuck in this. I think the whole solar panel is going to have to come out. I may have to prise the solar panel off, and I'm going to short this out. Is the alarm off yet? It will be off in a moment. So I'm going to pull this wire out here and fold it up. Oh no, I'm a bit scared now. And this wire, which I like the way they've used 2 red wires to indicate the 2 different connections, positive and negative, from the solar panel. I'm kind of thinking that the solar panel may actually have that battery, the lithium battery, actually stuck to it. Oh, you did? Oh, it might be glued, or is that jammed?
Something in it that, you know,
This is a bit precarious. This thing is glued in here. Oh, it might actually have a bit of foam under it to actually wedge it in. This is where that ruler would actually come in quite handy. I'll poke it gingerly with a lollipop stick. No, that is just wedged tight. That is a sort of sticky pad holding it against the top. They've used lots of glue to hold everything in here. This is precarious. Let's try and get this solar panel pushed in. Oh, well, that didn't take too long. Is this thing going to... If I push this, is this going to slide out? Ugh. Yeah. Ugh. No, this is not turning out to be too easy. I think that might be a wedge they've jammed under it to try and keep it in. I don't want to push too hard in case this goes up in flames, particularly because you know what, I'm wondering if I should actually just cut these wires. I'm going to pause momentarily because I think this is jammed in really tight. Oh dear, well, one slight bloodshed later. I didn't realise I was just trying to get this out, just how sharp that edge was, really, like razor sharp. This thing is wedged in. The solar panel is pretty much stuck onto the lithium pack in here, and then they've got a foam pad stuck under here, and the lot is just squeezed in tightly, so that once it's in, all the tension of that just holds the solar panel up against here. The circuitry is interesting because it's pretty typical of the sort of things you'd find here. I'm just going to zoom in on this. Let's zoom in a bit, because I've managed to find, let's also make sure that's fully in focus. I've managed to find the actual chip number on here as a data sheet, so let's actually nudge back out a bit because it is a wee bit too close. So this is an IP5108E in here, and it's a sort of universal power bank chip, and the connection, although it doesn't show in the schematic the actual manufacturer's data sheet, it doesn't show the connection of a solar panel. It's not really designed for use as a solar panel. So all they've done is the micro USB in, they seem to have just touched the solder connections for the solar panel onto that, and rather annoyingly, both the solar panel connections were red, which was a bit odd. This chip has an interesting facility. It does everything you'd require, but it shows the 2 amp and the 1 amp USB ports, and the main difference is that whereas the USB port A, which I think is the 1 amp one, just has pins 2 and 3 shunted, the other one has that little resistor array across it here, which presents the desired voltages to make it into a 2 amp port. It's the only real difference, that other than that, the 2 ports are in parallel.
Oh, I'm not 100%
yes.
sure.
Yes, I am 100% sure about this one, Vince. The LEDs, the 4 LEDs that indicate the charging state, they're down here, are multiplexed onto 3 pins, and there's also, there are 4 pins, one L1, L2, L3, L4, but L4, if it's taken to the regulated voltage that this unit uses for its own power supply, then it will use these just as a bar graph indicator with percentages of 3, 25, 50 and 75%. That's why when it gets down to 1 bar and it's showing 3%, that's why it suddenly falls off beyond that. However, if you leave the L4 floating and you don't connect to the regulated voltage, it then puts out I2C data, so you can connect a separate microcontroller, possibly even just built into the display itself, and that then presents, the chip can then be interrogated presumably for voltage level data, which it can then display on an LCD. I'm not sure how much information it can get from this. The data sheet is quite heavily in Chinese, so I'm not sure if it can accurately give just a voltage level or an actual percentage level out, or whether the MCU just works that out itself and gives a rough indication of what the potential capacity is. So that's quite interesting. I'm going to keep a hold of the data sheet number, because I think this same chip crops up in a lot of equipment. Yes, Vince, can I help you? It's quite interesting. It's a well-crammed power supply. It looks as though it's got a fairly high capacity, though I've not been able to test it. And the circuit board is very generic. It's very standardized. Yeah, I'd love a profiterole. Yeah, I'll have a profiterole afterwards. Thank you. I don't want it all over the. But profiteroles are next. I'm a bit suspicious about that sauce. Have you done something to that?
One bit. it?
It is actually. Oh, you've heated it. It's hot sauce. Okay, rightio.
Oh.
Yes, indeed.
Oh.
And that concludes this video. So now I'm back in an area where my work colleagues can't assist me in the video. Let's take a look at this module here because it's got one extra feature that isn't in the documentation. Most of the things are in the documentation. There are a couple of things worthy of note. The 1 microhenry inductor, it's marked, as so many of these are, as 1 RO. I'm guessing to me 1 RO usually means 1 ohm, but in this case it is an inductor, and I guess if they put an H there, it might imply it was a 1 Henry inductor, which would be massive. So it's a 1 microhenry inductor as it is shown in this schematic. And other things worthy of note are the cluster of capacitors on the output. Instead of using a 100 nano decoupling capacitor, which is often used just because the smaller capacitors are good at absorbing spikes and transients, they've also got 10 microfarad and 222 microfarad, and that gives a total of about 54 microfarads roughly. I wonder if they've done that because it's maybe the smaller capacitors are much cheaper and easier to get, so they just use a cluster in parallel, or it's because combined like that they have a lower equivalent series resistance that they're better at absorbing this sort of noise and transients from the switching. Other things worthy of note. Yes, the circuit shows the lithium cell connected. Not sure why they show 2 cells in series connected to this. I don't know if maybe this can handle larger arrays, but it doesn't show any extra protection, but I'm guessing it does have protection built in. However, on this circuit board, they've got the DW01Z and 2 MOSFETs, or DW01Z if you prefer that terminology. But they've got the standard arrangement of that protection chip with its 2 MOSFETs that will provide overcurrent and over discharge and overcharge protection. So there are 2 layers of protection, and it's not depending entirely on this chip. I guess that's quite good because the more layers of protection the better, particularly given that was quite a large pack of lithium cells. I wasn't able to test them for capacity. I don't have equipment to test them like that with me. Other things, the circuit board looks like it's never been designed to operate with a solar panel. So what they've done, the input charging port has 2 test points on the circuit board, and they've actually just tacked the solar panel across the input port on that. So ultimately, even if it's unplugged, if it's in sunshine, it will be charging. But it does mean that if you had a charger plugged into that, and the charger was just lying down, not plugged in, it would backfeed to the charger, and that would probably sink some of the current from the solar panel. I suppose it's just a simple fix that lets them add the solar panel. The construction of the thing, it was very tightly packed. Well, I cut myself quite badly on the case trying to slide the combined sandwich of battery and solar panel out because they were all stuck together with double-sided tape, and there was foam in the bottom, and it was such a tight fit that even pushing as hard as possible down, it was very hard to slide. It was kind of gripping it. The only way I can think they got those in is to actually put some sort of film or very thin metal strip that was sandwiched was fed in and then used to drag the whole package in, and then let the solar panel just locate itself on the square cutout in the panel. I cut myself quite badly, and Vince also had a go at trying to get out, and he cut himself quite badly. We ended up sawing the metal to actually get that open and get the whole thing out, and that's when we found that we initially thought maybe the lithium cell was just slid on under the solar panel, but the 2 of them were stuck together, and not in a way that would be easy to get apart, which is a shame. And it definitely means it won't be going back together, which is an equal shame because it looked like a fairly decent unit. So overall thoughts about this. It's a very simple implementation. It's very nice to see the chip identified, in this case an IP5108E. And it looks like a fairly textbook example of what would be required in a power bank like this, including driving the 4 LEDs and with the button for enabling the LED. There's the LED, the general illumination LED there if you want to use it as a torch or flashlight. It's got a 20 ohm resistor and series the LED, and then it's got the little button here that wakes the power bank up, and also when you hold it for a while it switches on that LED. Other things worthy of note, it says VREG 3.1 volt 50 milliamps, and I'm guessing that's the built-in regulator, and it could be used to power auxiliary circuitry like the LCD displays and their backlighting perhaps. So yeah, it was a fairly neat power supply. It was a fairly textbook power supply. and it was quite fun, albeit slightly dodgy, taking it apart.